All right, let's start talking about how chemicals walk the line. This is a PowerPoint explaining the how to balance a chemical equation. The quote that we have is, "You can't walk no line." That's June Carter. We're gonna look and see how and why chemical equations have to walk that line and have to be balanced. Our learning goals, what we're trying to achieve here. Students will understand how the law of conservation of mass affects a chemical reaction. So, what is the law of conservation of mass and how do we use it in a chemical reaction? Students will be able to balance chemical reactions by adjusting coefficients, and I would highlight coefficients, it's very important. And we only adjust the coefficients. So we're going to learn what the law of conservation is, why we have to balance, and then we're going to look at how we balance. Okay, so why do we have to balance? We have to balance a chemical equation to obey the law of conservation of mass. What the law of conservation of mass, very simply, the simplest definition of what we can have is what you start with has to be what you equal with or what you finish with. Okay, they have to equal each other. So if we start with 15 grams, we have to finish with 15 grams. It's just what's going to end up. Okay, remember that laws in science, they don't get broken. Okay, so it's been tested over time, and this is what happens. Okay, it's the qualitative solution using unbalanced equations are invalid. So anytime we have chemical equations, the reason why we want to balance them is so that when we actually use them in math, that the math actually turns out right. If we don't use a balanced equation, then none of the math that we do with the chemical equation will be right. Okay, so if we don't balance, we forget to balance, then everything else is wrong. So, big important step, we got to balance. So, what changes to balance an equation? Okay, so biggest thing here, and this is the biggest thing probably we've talked about in a while, the coefficients are the only thing that change to balance a chemical equation. Nothing else changes. What should not change to balance the equation? And these are common mistakes that people make all the time, and this is what you do not want to do. Never change the subscript. So say I'm working in a chemical equation that has water. I can't just go, oh, well, I really needed only one hydrogen, so I'm just going to erase it 2 and just make it a 1. You can't do that. Okay, if I change how many hydrogens are connected to that oxygen, then I've changed the chemical formula and I've changed what I'm dealing with. Okay, it's not the same thing. Another thing that we can't do is never put a coefficient in the middle of the formula. Okay, remember what coefficients are. Coefficients go in the very beginning. They go in front of formulas. So I say I put a 2 right here. That's my coefficient. That means that I have 2 water molecules. So basically what that means is that 2 gets distributed to everything. So now I would count 4 hydrogens and 2 oxygens because that's what I have. Okay, but what I can't do is I can't go, oh, I really need 2 oxygens, but I don't need any more hydrogen, so I'm going to put a coefficient right there. You cannot do that. That is wrong every time. The only thing that changes are the coefficients, and we change them in front of the chemical formula. Okay, how do we balance a chemical equation? These are the steps that you take. Okay, all numbers of atoms on the reactants must equal the number of atoms on the product. So they have to equal up. Okay, to do that, this is where we start. The first thing, we start with a correctly written equation. So we got to make sure that the equation that we actually write out is the right equation. If we mess up on writing a formula, it totally changes it and we can't balance it majority of the time. Or we balance it incorrectly and they get the wrong coefficients. So, big step. Start with a correctly written equation. Then, where do we start from there? Where do we go from there? We balance the number of metal atoms on the products and the reactants. Okay, so we do metals. Then we balance the number of polyatomic ions on the products and the reactants. Then we go to ions. Then we balance the number of nonmetals on the products and reactants. Then we balance the number of oxygens. Then we balance the number of hydrogens. We save that to last. Kind of a little acronym for us to remember this. Metals, ions, nonmetals, oxygens, hydrogens. You can think of that as MENO. So metals, oh, let's use a pen there. Metals, ions, nonmetals, oxygen, hydrogen. One way you can remember that, and that's just the order in which you want to balance. Okay, so let's look at the steps in action. We start with a correctly written equation. That's what we have here. It's correctly written, and we have it written out for us. We see that we have our copper 1 fluoride plus our sulfuric acid and oxygen, and we see that it produces our copper 1 sulfate and our water and our fluorine. So, first thing we look at is we balance the number of metals. We start with metals. So, the metals that we have, well, we have our copper. And we see that the coefficient here is 1. Okay, not the coefficient, but the subscript. We have 1 copper. And then over here, we have 2 coppers. So we have to balance it out. So to do that, we'll just put a 2 coefficient in front of our copper. And we see that it balances it out. Okay, the next step, now that we have our metals balanced, let's balance our ions. So what's an ion here? Well, there's a polyatomic ion right there. We see that we have 1 sulfate, and then on this side we have 1 sulfate, so it's balanced. So that's good. Next we move to our nonmetals. Well, the nonmetals that we have fluorine and fluorine. Okay, so in looking at this, we already put a 2 here. That 2 distributes to that fluorine, so we really have 2 fluorines there. Okay, so we have 2 and 2. They're balanced. Then we move on to the number of oxygens. Now, you see these oxygens right here? Well, they're part of an ion, so really don't count those. Just count the oxygens that we have. Well, we have 2 right here, and then we have 1 right there. So to balance this out, we just put a 2 coefficient there. And we see that it balances out our oxygens. Then we move down to lastly, our hydrogens. We see that we have that 2 distributes out to that, so 2 times 2 is 4. That's where we get our 4. And over here, that 2 distributes out there as well, so 2 times 2 is 4. So we have 4 on that. So let's look at our first example. It says Sp4O5Cl2 has a very unique property or properties and can be produced from a chemical reaction. So it gives a chemical reaction between solid antimony oxide, antimony 3 oxide, and antimony 3 chloride. And it says, what is the balanced chemical equation? So we see that what's produced is that formula. Okay, that Sp4O5Cl2. That's what's produced. So the first thing we have to do is we have to write our the correctly written chemical formula, which we have to have the chemical equations for these guys. So it's just Sb and oxygen, and this is Sb and chlorine. So we have to go ahead and crisscross because these are ionic compounds. So remember what that 3 means. It means it has an oxidation number of +3, so +3 over here. And then we have our oxygen is -2 and chlorine is -1. So we go ahead and crisscross these guys and bring them down, and we get Sb2O3 plus crisscross SbCl3. Okay, and then it produces our product Sb4O5Cl2. Okay, now that we have our correctly written equation, we can go ahead and start balancing it out. Now, what I like to do when we do these, go ahead and arrange everything so we can keep it all nice and neat, and arrange it so that we can count everything out. So what's involved in the chemical reaction? Well, it's going to be our Sb, our oxygen, and our chlorine. This is what we have involved in the reaction. So I like to write it. So look on the reactant side. Sb, we have 2 right here plus 1 right there, gives us a total of 3. On the product side, we see that we go ahead and we have 4. Okay, so that's not balanced. Oxygens, we have 3. On the product side, we have 5. So we have 3, and then we have 5. And then our chlorine, we have 3, and then we have 2. Now, when we're looking at this, the one thing that we can think of to balance this out, the first thing to do to kind of balance out our metals. Okay, so to do that, we see that we have 2 right here and 1 right there. So to balance it out, to make it 4, what we can do is add a 2 coefficient right here, which that distributes out to our antimony and our chlorine. So we go ahead and we see that now we have 2 plus, remember this distributes out, so 2 plus 2 is 4, and our chlorine goes from 3 to 6. Okay, so now that that's balanced, let's go ahead and go back and let's balance our chlorines. All right, so to do that, we have 6 on the reactant side. We have a coefficient of 2 right there, so how do we make it 6? Well, we just go ahead and we put a 3 right there. Okay, and it balances out. And now that changes a lot of things on our product side. So it changes, remember that 3 distributes to everything, so it changes that to a 12. Our oxygen changes to a 15. And our chlorine changes where now it's balanced at a 6. Okay, so when we're looking at this, we need to go back and we need to balance again. So what we can see is we have a 2 right here, 2 and 2 is 4. We need 12. Okay, so we don't want to keep adding it there, so let's try by adding here. So if we have 2 right there, 12 minus 2 is 10, so this needs to be a 10. How do we make that a 10? Well, we go ahead and we put a 5. Remember that 5 distributes out. So now our metal, we have 2 times 5 right here. That would be 10 plus the 2 that we have over here, so that's 12. Our oxygen would go from 3 to 15. Okay, and we see that now everything's balanced. Everything's the same on both sides. Let's do another example. Here we have our word equation, so it'll be a little bit easier to write it. So we have copper, which is Cu, plus silver nitrate. So let's go ahead and write that. It's a polyatomic ion. We have silver, which is always plus 1. And then our nitrate, which is NO3, it's negative 1. So crisscross and we get AgNO3. Produces silver, so Ag all by itself, plus copper to nitrate. So we're looking at this, so copper is Cu plus 2, because it tells me right there, and then nitrate NO3, negative 1. Crisscross, and we bring that 2 down, and we have our 1 right there. So we get our Cu, parentheses, NO3, and we have 2 of those guys now. So let's go ahead from here and go ahead and balance. So what do we have involved? We have our copper, we have our silver, we have our nitrate, which is our ion. So our copper, we have 1, silver, we have 1, nitrate, we have 1. On our product side, we see that silver, we have 1, copper, we have 1, and nitrate, we have 2. So our metals are already balanced, so we can move on to our ions. Let's make our ions balanced. So we'll go ahead and put a 2 right here. Remember, it distributes to everything, so it does distribute to the silver and to the nitrate. So our silver would go to a 2, our nitrate would go to a 2. So now we don't have any oxygen or hydrogen, but we need to go back and make sure our metals are balanced. We see that copper is still fine, but silver's not. How do I change this? Silver on my product side, well, I'll just put a 2 right there. It distributes just to that silver, and we see that it now goes to a 2, and we have a nicely balanced chemical equation. Last example. We see that it's already written for us, so it's given us the equation. Let's just balance it out. So we have iron and oxygen, 2 things. So on the reactant side, we have 1 iron and we have 2 oxygens. On our product side, we have 2 irons and 3 oxygens. So let's go ahead and balance these out. Start with our metal. So that's pretty simple for us to balance. We can put a 2 right there, which it goes ahead and it balances it out for us. Now we go to our oxygens. Now we have a 2 and we have a 3. What do they have in common? Well, 6. So let's make them both a 6. So to do that, I put a coefficient of 2 there. But remember what it changes. It changes everything. So it changes everything of that equation. So iron would now be 4. Oxygen would be 6. Okay, so let's go back and make sure that our metals are balanced. That 2 doesn't work anymore. It needs to be a 4. So 4 times 1, there we go. That now becomes a 4. And now all we have to do is balance out our oxygen. So that's a 2 right there. So 2 times 3 is 6. So all we would do, that would go to a 6. Everything's balanced. There's our nicely balanced chemical equation.